Now we're going to discuss slices. Slices are kind of like arrays, but they are dynamically sized. But underneath they reference an array. So previously we talked about arrays here, how they define a specific size. Slices are very similar in how we create them. There's actually a couple different ways to create them, but let's do it one of the normal ways. And we're not specifying a size here. So this means this is going to be a slice instead of an array. If you specify a size here, that creates a fixed size array and not a slice. Let's print this out. Okay, so now the slice is empty. Now let's make a printer function, and we're going to pass in the slice, which we're going to call it names, which is an array slice of strings. Let's first print out the values and then print out the pointer, and then we're going to print out two lengths. Okay, so let's do this with names, then the pointer location, because a slice is really just a reference to an array. So you can see we printed that twice there. Now there's two built-in functions that we're going to use. One is called len, which gives you the length of the array, and then another which is cap, and that will tell us how much actual memory is being used for that array. All right. So we also don't need to specify a pointer here or an address because this is already built into this syntax here. Let's print this. So now we can see that the slice is empty. It does reference a location. However, at the location, there is actually no space there. 0 for length and actually 0 capacity. Now let's print out an empty slice here. Let's run this. And you can see that the values are empty, but it does have a location, but it also has 0 length and 0 underlying size. Now that's because we instantiated it using this method. This actually creates a slice, an empty slice. Now if we change this to var names, did it this way, and rerun it, we can see that the memory location is really 0, and there is no data there yet. And you could actually do an if names equals nil. Names is nil. Right there. So let's back this up and go back to the other way. Okay, so let's say we add a couple variable names here, Nick and Bob. Now you can see that the size is 2, the length, but also the capacity is 2. So what would happen if we want to add another name onto this array? How do we do that? Well, we do that with the built-in function called append. Append will take a slice, type, and then also the elements of the next value you want to put on there. And it'll actually return a reference to the next one. So what we would do here is names, and then we could say Frank. Now, what we want to do is we want to overwrite the existing variable name here because we're adding Frank onto it. Now let's print this and see what happens underneath. Okay, so when we printed the first version, you can see the pointer location here ends in 2020. It has 2 length and 2 capacity. But when we added one more, something different happened. So you can see the location here is different than that location, and also it increased our size by 2. So we now have a capacity of 4, even though we're only using 3 spaces in there. Now, this is how a slice is dynamically sized. We don't have to worry about how big the capacity will be. It will automatically reallocate the underlying array into a different memory location and add Frank onto there. Now what happens if we do this again? Let's do this. Now we can actually see that after we added Joe, the location is the same and we're actually using all capacity here. Now this could be a cause for concern in some applications where you're assuming you're only increasing memory usage by 1 item when you're really adding 2 more because it had to reallocate the array. And that could actually cause a lot of memory pressure in your applications, where if you're allocating and deallocating a lot of memory by appending and not being mindful of the underlying data, that could cause some memory and performance problems in your application. So it's good to know what is actually happening underneath within your slices. Now let's play around with the internals of a slice using the range operator. So let's create a group. Let's just call it group 1. And we're going to take the first 2 elements. So you do that by using a colon. So we could say 0 to 2. This is not inclusive. And let's print this and see what it does. So the other 2 print statements right here, these 2 are printing at this location. You can see that the underlying location of the memory here is the same for these 2 print statements, and it's also at the same location for this new variable we created. And that's because the underlying array hasn't changed. We're basically just pointing to that value, which has a length of 2 and a capacity of 4. Let's remove some of these prints so it's a little bit easier to see. We can actually change this up here. So you can see these 2 locations are the same, A6040, just the length is different. Now to test this out, let's change group 1. Let's change the first value to Chris. Now we're going to print out both group 1 and names. So we can see that the memory location is the same for all 3. And when we change Chris, we can see that it's Chris Bob here in this group 1 variable, but also it's changed in this one because it is a reference. So you have to be mindful when you create a slice from another slice. Now let's do another thing with slices, which is we can take certain sections of a slice out. We can specify just the first 2, we can specify the last 2, or even capture some of the values in the middle of a slice. So we can do that with the colon operator. So we can say 0 to 4, which would give us all 4 elements. That's one example. This is the same as specifying colon with nothing in the middle. And also it's the same as this value here. So that's the entire array. So let's capture the first 2, which could be 0, colon 2, or we can remove the lower bound because the default value of the lower bound is the beginning of the array. Now let's say we want to capture the end of the slice, and we could start at 2 and go to 4, or we could omit the 4 because the default of the end is the length of the array. So 2. So 2 colon here does this. And we can see that names prints out the same as names 0 colon 4. And just for showing everything, we can see that the first 4 print statements are exactly the same because we are already using a slice here. This is actually creating a slice of that slice, which is just a reference. Now, these colons make it very easy to work with, say, lists and stacks. You can also use it to work with strings and characters. There's a lot of different use cases for using these upper and lower bounds. Now let's go over how to iterate over a slice. I'm going to show you 2 different ways. For I equals 0, and this is just like in the basics lecture, except what we're going to do here is we're going to use the built-in function to capture the length of the slice. And then we're going to iterate by 1. And let's print out each name. All right, so that's one way to do it. Now, because we're using a slice, there's a much easier way to write this. And so what we're going to do is we're going to use a range operator. So what a range operator actually does is it returns 2 variables, and we're going to call this I for the index and then name. And you'll see how this looks. And it looks just like this. Range is the operator over names, and we're creating a variable. We're actually creating 2 variables, I and name, because the first variable is the index and the second variable is actually the value. So let's print out the name here. And you'll notice we have an actual error here because we're not using I. So you can either use that variable, or what you can do is use an underscore to ignore that return value. And this prints all the names as well.